In this video, we are looking at composite functions. Now on this slide, we have definition of composite function and how it works. So let's go straight to the point and explain the basic concept of composite functions. The composite function of f, or the composite function f of g of two functions f and g, is defined by f of g all of x equal to f of g of x. Now what this equation means is that now the functions f and g are all functions of x, and this can also be written as f of g of x. Now the domain of f of g is the set of all x in the domain of g, such that g of x is in the domain of f. We need to note that the order of composite function is very important. Thus, f of g of x is not the same as g of f of x. Now let's try to explain the second line. That is, say that the domain of f of g is the set of all x in the domain of g, such that g of x is in the domain of f. Assuming you have a function f of x now when you have a function f of x and another function g of x, now these are two different functions which are all functions of x. Now let's look at f of g. Now the composite function f of g here means we are going to locate x in the function f. So x is the domain of the function f. And so what we are going to do is that wherever we see x in the function f, we are going to replace the whole function of g to x, what is the domain of the function f. So that is the meaning of this statement, that the f of g is the set of all x in the domain of g, such that g of x is in the domain of f. So wherever we see x in the function f, we are going to put the whole of function g to replace x in the function of f. So let's look at some example here, or examples to explain further that statement. So assuming we have function f of x to be 3x plus 4 and function g of x to be 3x minus 10, and then we want to find f of g. So f of g, or the composite function f of g here, means wherever we see x in a function f, we are going to replace the whole function of f into wherever we see x in the function f, we are going to replace that x with the whole function of g. That is the meaning of the domain of f of g is a set of all x in the domain of g, said that g of x is in the domain of f. So this f, the whole function g, becomes the domain, or becomes the x of the function f. Okay, so f of g, as I said, we are going to replace the whole of the function g. So the function g here is 3x minus 10. So we are going to put the whole function of g, which is 3x minus 10, into g wherever we see x here. So we have 3x, but x is going to be the function of g. So that's going to be 3x minus 10. So we are done replacing the whole function of g into x. Then the next term of the function f is plus 4. Now when we are done with this, we need to expand or remove the brackets by multiplying 3 by those in the brackets. So 3 by 3x will give us 9x. 3 by 10, negative 10 will give us negative 30. Then plus 4. So 9x, negative 30 plus 4 will give us negative 26. So that gives us the function f of g. Now let's look at it in this way. The function g of f. So this one also means that we are going to replace the whole of function f into g. But where do we put f into g? Wherever we see x in the function g, then we replace the whole function of f into it. So now the function f becomes the domain of g. So the function g, we have it to be, so let me repeat it, g of x is 3x minus 10, and then the function f is also given to be 3x plus 4. So the focus is g of f. So wherever we see x in g, we put the whole function of f into it. So our g is, so g of f, so g is 3x. But what is x here? This x is going to be replaced by the whole of this function f. Okay, so we have 3x plus 4 minus 10. So we need to expand the bracket. 3 by 3 x will give us 9x. 3 by 4 will give us plus 12 minus 10. So g of f, g of f is now equal to 9x plus 2. So that is that.